You know that feeling when you're on a merry-go-round and you feel like you're being pushed to the side? It's a simple force of physics, right? Well, what if I told you that exact same force could be used to solve one of the biggest, messiest problems in industry? Today, we're going to dive into how the simple power of spin is literally turning massive amounts of waste into value. So let's start with a big question. Imagine you're dealing with thousands upon thousands of gallons of industrial sludge. How in the world do you clean it? This isn't just a hypothetical. It's a massive daily challenge for some industries, and it touches on everything from cost and logistics to environmental safety. The source of the problem is the stuff called slurry, or sometimes drilling mud. It's this really thick, complex mix of liquids and superfine solids. You can't just dump it. For one, it's incredibly expensive to manage, and two, you'd be throwing away valuable materials mixed in with all the gunk. It's a real headache. So how do we tackle a problem like this? You might think it requires some crazy chemical process, but the solution is actually much more elegant. It's pure, powerful physics. It all comes down to the power of spin. And the principle we're talking about is centrifugal force. We've all felt it. It's that outward push you get on a spinning ride at the fair. The faster you go, the stronger that push gets. Now imagine taking that simple force and cranking it up thousands of times. That's when you can start to separate things with incredible precision. And this is the hero of our story. This is an industrial decanting centrifuge. It might look like a complicated piece of machinery, but its whole job is to take that centrifugal force we just talked about and use it to do one thing really, really well: separate the heavy solids from the lighter liquids in that thick slurry. To really get what makes this thing so effective, we've got to look inside. How does it take this uniform, messy sludge and just unmix it? Let's break down the process. Okay, so here's the play-by-play. First, the slurry gets pumped right into the heart of the machine. Then the outer bowl starts to spin. And I mean really spin, at incredibly high speeds. We're talking about generating thousands of Gs of force. That's thousands of times the force of gravity. This immense force just flings the heavier solid particles outward, packing them against the inside wall. At the same time, there's a big screw inside, an auger that's rotating at a slightly different speed. It scrapes all those packed solids and pushes them toward one exit. And the cleaner, lighter liquid? Well, it's left floating on top and it flows right out of a separate exit. It's this constant, seamless separation process. But here's what's really cool. This isn't just a brute force machine you turn on and off. It's more like a high-precision instrument. You can fine-tune everything: how fast you pump the slurry in, the spin speed of the bowl, the speed of that internal conveyor, even the liquid level, or pond depth inside the machine. By adjusting these variables, operators can dial in the perfect settings to get the cleanest separation possible for whatever kind of mud they're dealing with. So, after all that incredible spinning and careful tuning, what are we left with? What actually comes out of the two different exits? Let's take a look at the end products. And here you have it. This is the goal. What went in as one big, useless mess comes out as two very distinct streams. On one side, you've got your solids, and on the other, your clarified liquid. You've successfully deconstructed the waste. And let's get a little more specific. Those solids come out as a dense, almost dry material they call a cake. Think about the spin cycle on your washing machine. It's the same idea, wringing all the liquid out. The liquid that comes out the other side still has some ultra-fine particles in it, stuff that was just too light to get separated. But it's way, way cleaner, and there's a lot less of it than what you started with. Okay, the mechanics are fascinating, for sure. But why is this so important? What's the real-world impact of this technology? Let's zoom back out and look at the big picture. The difference is, honestly, night and day. Before using centrifuges, an operation would be stuck with these huge volumes of liquid waste that cost a fortune to transport and get rid of. Plus, valuable materials, like that barite we mentioned earlier, were just being thrown away. But after you bring in a centrifuge, the waste volume plummets. That valuable barite gets recovered and can be put right back into the system. It saves a ton of money and resources. So just to recap the main benefits here, because they're huge: you get to recover expensive materials and use them again. You dramatically cut down on the amount of liquid you need to dispose of, which in turn slashes your disposal costs. And critically, it helps these operations meet strict environmental regulations. It's a win-win-win. It's also really important to understand that this centrifuge isn't working all by itself. As you can see here, it's actually a key player in a much bigger system for controlling solids. You'll often have other equipment like shale shakers that get rid of the bigger, coarser stuff first. The centrifuge is like the special forces. It comes in at the end to handle the ultra-fine particles that nothing else can touch. All of this brings us to one final big idea. This technology proves a really powerful concept. Something we call waste can often just be separated back into its valuable parts. So it makes you wonder, right? What if we could apply this same kind of thinking everywhere and spin the waste from every industry back into something useful?